will share my screen. Okay. So can you see my screen? Can you hear my voice?
Yes, Doctor.
Okay, thank you for the response. Okay. So last week we have learned up to this slide, which is the type of communication systems. Okay, how can we see the different types of communication system about this one? So maybe before we proceed, maybe we can refresh again what we have learned last week. Okay, so if I go back to previous slides, okay, about this topic, okay, types of electronic communication. So how can we classify the communication system? Okay, we can classify into three categories. We can classify according to transmission mode. We can classify the communication system according to analog or digital system. We also can classify the communication system in terms of baseband or broadband transmission. Okay, so ada tiga cara untuk kita classify the types of communication. Okay, and for the first one, if we can classify the communication system according to its transmission mode. Okay, as I mentioned in the last week, that this is the favorite questions in the test and also in the final exam. We have answered this many times in the previous semesters. Okay, kami telah tanya banyak kali tentang about these slides. Okay, so in the previous question also explain about the transmission mode in the communication system, one way and two way. Okay, so you need to explain one way simplex means that signals travel in one direction only. So this is mainly used in the broadcasting system, where the signal only transmit in one direction. So broadcasting, for example, like television, like your radio system. So for example, like television, you only see and listen to the television, but you are not communicating to the television station. Okay, you are seeing and listening to the television. Similar with the radio, you are listening to the radio. You are not transmitting any signal to that radio stations. So this is kind of broadcasting system. Okay, and then the second types, one way is for the simplex, what we call as a simplex. We have another one is what we call as a two-way, which is the duplex. So the duplex consists of two categories, half duplex and full duplex. Okay, so half duplex, both communicators, both persons, transmitter and receiver, can send signal, but only one at a time. Okay, so in this case, for example, like the police radio system, or maybe you can if you know that about the walkie-talkie. Kalau siapa yang pernah guna walkie-talkie, if you have used the walkie-talkie before, so when you use the walkie-talkie, that means when you want to talk, the other person will listen, and when the other person talk, you will listen. So the signals only travels in one direction at a time. Okay, but both can communicate, but only one person can send the signal at one time. Okay, different from the full duplex. Okay, the full duplex here means that the signal can travel in both directions simultaneously. So one of the example of this is the telephone system, where where both parties can talk at the same time. Okay, contohnya seperti sistem telefon yang mana kedua-dua pihak boleh berkomunikasi simultaneously pada masa yang sama. Okay, and then what? We can also classify the communication system in terms of either the system is analog or the system is in terms of digital. Okay, as I mentioned in the previous week about analog system, receive input as analog, process the signal as analog, and transmit the signal as analog. Okay, if you remember that I draw this picture last week. So this system receive analog, process the signal as analog, transmit as analog, okay, and produce the output as analog, also process in terms of analog. Okay, so all process involve analog signal. Not only in terms of wireless, it can also be done using the wire. Okay, and then what? Digital. So the good thing about digital is that we have the flexibility to process the input or to process the output signals as well. Okay, so for the digital, as I explained in the previous week, last week, that okay, so the good thing about digital is that we can receive either analog signal or we can receive digital signal. Okay, so put inside the transmitter will process as a digital, and we have the options either to transmit as a wireless, which is analog. If we transmit as a wireless, that means we are changing the digital code word into a electromagnetic waves. That means when we produce the electromagnetic waves, of course we will transmit as a wireless signal. Okay, and there will also be we can also transmit as a digital, where we transmit as a digital pulses, electrical pulses across the wired medium. Okay, boleh juga kita hantar secara digital pulses menggunakan cable, using a cable. Okay, and then process as a digital, and we have the flexibility to produce either analog or digital output. So this is the beauty of the digital system. We have the flexibility to receive and also to produce digital or analog signals. Okay, but in digital system, it will be further divided into two categories. So digital transmission. So this is about wired transmission. Okay, where we transmit the signal using a baseband signal. Okay, so where it doesn't involve modulation with the analog carrier. Okay, so in this digital transmission, we are not modulate the input with the analog carrier. Instead, we change it into the electrical pulses, and we transmit it in the cable, in the wired medium. Okay, so you see that there's no analog carrier. That means in digital transmission, here this one is a communication system that does not involve modulation with analog carrier. Okay, original source information may be digital or analog. Of course, we have the options, both of it. Okay, it requires physical medium between transmitter and receiver. So that means we are using the cable. Okay, so in this case, the transmitted signal is in the form of digital pulses or electrical pulses transferred between one point to another point. Okay, and for your information, this transmission system using low frequency, or what we call as a baseband, which we will see later in the next topic. Okay, and another one is digital radio. So in digital radio, that means we want to transmit the signal as a wireless. Why? Because we will do the modulation with analog carrier. Okay, when we do modulation with analog carrier, that means we will produce electromagnetic waves that can propagate in the wireless medium. Maknanya kita akan hantar secara wireless menggunakan electromagnetic waves. Okay, so we do the modulations with analog carrier in order to produce either one of these ASK, amplitude shift keying, phase frequency shift keying, and also either phase shift keying. So either one of these. So modulation will change the property of the carrier in accordance with the input. So what it will produce is either one of these modulation signal categories. Okay, so both of these are transmitted in the form of electromagnetic waves. Okay, so modulation signal and demodulated signal are digital pulses. Okay, so you see that even though we transmit as analog, but the information contains inside the signal are digital. Okay, so digital pulses could be originated from a digital transmission system, from a digital source computer, or binary encoded signal. Transmission medium may be physical facility or free space. Normally it is used in the free space, but of course it can also be done using the wired cable. Okay, but it is at high frequency. Okay, remember when we do the modulation, we translate the signal from low frequency into a higher frequency. In this case, we are using high frequency transmission. Okay, advantage of digital transmission. So there are many advantages if we use the digital system compared to the analog. What are the advantages? The first one is about the technology. So it is more low cost VLSI technology. In terms of data integrity, longer distance over lower quality of lines. Of course, if we use the digital transmission, we can transmit at longer distance with a high quality compared to the analog. Okay, because in digital system, later you will see that digital system is able to regenerate the signal when we want to transmit in a long distance. Different from the analog, we cannot regenerate the signal. Okay, dalam analog, we cannot regenerate the signal. Regenerate means that we generate again the signal. Okay, seolah-olah macam kita hidupkan dia semula. Signal itu apabila when the signal goes from one place to another place at longer distance, there gonna be some repeaters. Okay, between the distance. So the repeaters for the digital system means that it will regenerate the signal again, and we can transmit the signal in a longer distance. Different from the analog system does not have a repeater. Okay, where the signal cannot be regenerated. We can only amplify the analog signal. We cannot regenerate the digital signal. Okay, and then what? Capacity. So capacity utilization, we can achieve high capacity. Capacity means that we can support higher number of many users. Okay, means that we can do multiplexing of many signals. Why? Because all signals have only two possibilities. Either it is a logic 1 or logic 0. Okay, as I told you before in the previous week, that the data is in the form of logic 0, logic 1, logic 0, logic 1, and so on. So if all signals have only two possibilities, so therefore easy for us to do the multiplexing. So we can transmit many signals together across the medium. Okay, so therefore we can utilize high capacity in the transmission line. And then in terms of security, we can do the encryption only for the digital signal. Okay, but analog system cannot do the encryption. Integration, we can integrate with analog and digital data similarly. So this is what I told you before, that we can receive and produce analog or digital signal. Okay, and then what? Baseband or broadband. So we can classify the communication system either baseband or broadband transmission. Baseband means base frequency, broadband means broad frequency or broad bandwidth. So the keyword here is base and broad. Okay, this is related to the frequency spectrum. Okay, baseband using the base frequency dasar, or what we also known as a low frequency transmission. Okay, so baseband, if you see the frequency spectrum, it is starting from the 0 until a few kilohertz of frequencies. Okay, so baseband, so if you want to relate this one is related to the in the previous slide, which is digital transmission. Okay, this one. Okay, so baseband transmission, we are using the base frequency. Okay, so we are not modulate the input with the analog carrier. Okay, the frequency is still the same, the input frequency and also the transmission frequency is the same. There's no there's no change in the frequency of transmission compared to the input frequency. Okay, so kita menggunakan frequency yang sama daripada input. There's no frequency translation from low frequency to high frequency. Instead, we are using the same frequency from the input for the output. Okay, so baseband in digital signals are used, but it can also be used with analog technologies. Frequency division multiplexing is not possible because we are using a low frequency signal with a small bandwidth. So if you see from here, the bandwidth is small bandwidth. Okay, baseband is bidirectional transmission, short distance signal traveling. So this is normally for the short distance. Entire bandwidth of cable is consumed by a signal in a baseband transmission. So this is normally used in the wired transmission. Okay, normally used in the wired transmission. But of course, we can also transmit as a wireless. Okay, there's also possibility to transmit in a wireless, but normally this is used in the wired cable transmission, for example like the Ethernet. And then another one is a broadband transmission. So broadband, the word broad means bigger. Okay, big. So this is related to the bandwidth. Okay, means that we are transmitting using higher bandwidth. Okay, and if you see from the frequency spectrum, it is located in a high frequency transmission. Okay, until gigahertz, for example. Okay, a bigger bandwidth. So sorry, this is too big. Wait, okay, so above megahertz and above. So original signal is used to modulate a carrier for the transmission over the medium. So when we want to use a broadband transmission, we need to modulate the input with the analog carrier. Okay, we need to modulate the input with the analog carrier. Maknanya kita perlu melakukan proses modulation. Modulation translate low frequency into a higher frequency transmission. Modulation will change the characteristic of the carrier in accordance with the input. As we have learned last week, that there are three characteristics of the carrier that might be changed during the modulation process. Either it is amplitude of the carrier will change, or frequency of the carrier will change, or the phase of the carrier will change in accordance with the input. Okay, so proses ini memerlukan broadband transmission ini memerlukan proses modulation dengan analog carrier. Okay, and remember, this broadband means that it will use a wider bandwidth or broad bandwidth. So the size of the spectrum is bigger compared to the baseband. How many big? It depends. Okay, berapa besar? Bergantung. So broadband analog signal is used, okay, because we want to transmit as a wireless, okay, into the wireless medium. Transmission of data is unidirectional. Signal traveling distance is long. Frequency division multiplexing is possible because we have wider bandwidth yang besar. Make it the wider bandwidth make it possible to combine many signals together and send across the medium. Okay, so the signals are sent in multiple frequencies and allow all multiple signals sent simultaneously in broadband transmission. For example, like digital subscriber line, DSL, and also the cable television network. Okay, cable television networks, for example, your HIP TV, okay, Astro also have the cable television networks. Okay, and then what? So this is the picture of types of communications. For example, like the telephone system. For the telephone system, you see that we have the analog data, okay, and we transmit as an analog signal. Okay, so you're gonna see later that the word data is normally referring to the input. Okay, data, and the word signal is normally used for the thing that we send across the medium. Okay, the thing that we send across the medium is normally we use the term signal. So there's going to be interchange among both of these. So apa beza data, apa beza signal? So data normally referring to the input, okay, or the information contains inside it. Okay, so how we want to transmit the information? Either we want to transmit as a analog or we want to transmit as a digital pulses. Okay, so telephone system, we receive analog, we transmit as a analog. Digital data, we put inside the modem, and the modem can transmit as a analog. So we have the options like this. Codec, we have an analog signal, we transmit as a digital signal. So when we receive a analog signal, we can do the encoding process inside a digital system. We encode it and we transmit it as a electrical pulses. Okay, digital transceiver means transmitter and receiver, both of it. Okay, both. So we can receive a digital data and we can transmit as a digital data as well, using the electrical pulses. That means we will do the encoding process and we convert it into electrical pulses suitable for transmission. Okay, so you see that there are many variations of input and output combination. Okay, we can receive analog, we can receive digital, and we can transmit in the form of analog, or we can transmit in the form of digital. So you see that we have the flexibility for this one. Encoding techniques. So encoding techniques. So how can we do the encoding techniques? So from the previous discussion, it is obvious that we can have 4 types of transmission system. We can have a digital data, and we can transmit as a digital signal. We can have analog data, we transmit as a digital signal. We can have digital data and transmit as an analog, or we can have analog data and we transmit as an analog signal. So there are 4 combinations that we can do. Okay. For example, digital data and digital signal. Okay, so what you need to know is timing of the bits, when they start and end, signal levels, factors that affecting the successful transmission, interpreting as signal to noise ratio SNR, data rate, and also the bandwidth. So example of non-return to zero. So this is actually like this. So for example, okay. So this is normally for the wired transmission. So you see that we have the digital input, digital data. Okay. So the transmitter process it and produce digital pulses or electrical pulses at the output. Okay. So you have the input digital data in the form of 101010, and the issue now is how can we transmit this digital code word into electrical pulses. So that means we need to use a line coding. What is line coding? Line coding is a coding system that do the process of encoding and decoding. Encoding in the transmitter, decoding in the receiver side. So the line coding is this one. All of this is what we call as the line coding. We have NRZL, NRZI, bipolar MI, Manchester coding, differential Manchester, and many others. Okay, so the line coding technique is the encoding technique that convert digital data into electrical pulses suitable for transmission across the medium. So you see that in this case we are not using analog carrier. Dalam kes ini tidak melibatkan analog carrier for the transmission. Okay, and then what? Digital data, analog signal. So you see that we have digital data above here, digital data from in the form of 101010. Okay, so we want to transmit as a analog. So you see that we want to transmit either of these three, ASK, BPS, FSK, or PSK. Okay, so this is for example using in the telephone system. You can use a modem or modulator or demodulator. So in this case, okay, which is normally in the wireless system, okay, so you see that so I draw it like this. So this is the transmitter. So you have the digital data, okay, digital input, and for example you want to transmit as a wireless. Okay, in order to do that, that means you want to transmit as an analog. In order to do this, you need to modulate with analog carrier. Okay, you need to modulate with analog carrier. When you do that means you want to modulate the digital data with analog carrier so that you can transmit as an analog. So when you do the modulation, of digital data and analog carrier, you will produce either of these three, ASK, FSK, or PSK. Okay, so if the modulation if the modulation process change the amplitude of the carrier in accordance with the input, you will produce amplitude shift keying. If the modulation process change the frequency of the carrier in accordance with the input, then you will produce FSK, frequency shift keying. If the modulation process change the phase of the carrier, in accordance with the digital input data, then you will produce phase shift keying. So you see that you can transmit either of these three. Okay. And then what? Analog data, digital signal. So that means if you see from here, okay, so you have analog input and you want to transmit as a digital in the form of pulses. Okay, dalam bentuk pulses, voltage or current. Okay, so you have analog, you want to change it into digital pulses. So this is involve the process of digitization. Okay, involve the process of encoding and decoding. Okay, so in this case I see that conversion of analog to digital data inside the transmitter. Digital data can then be transmitted using a digital encoding such as NRZL. So of course this analog will be processed as a digital data inside the transmitter and then will be converted into digital using a line coding. Okay, one of the example is a line coding. Digital data then be converted to analog signal, analog to digital conversion done using a codec. So for example of this application is in the application of pulse code modulation or delta modulation. Okay, this is PCM, this is DM. Okay, so this is an example of the changes from analog to digital output. Okay, PCM, so you will do this in your project task number 2. Later I will explain about this. Task 2. So this PCM you will learn in chapter 4 later. Chapter 4. Okay. The fourth category is you have analog data, you transmit as analog signal. So you see that here, for example, transmitter, you have the analog input and you want to transmit as a analog. Normally this is wireless transmission. Okay. In order to do this, you need to modulate with analog carrier in the transmitter. So modulation process again will change any of the characteristic of the carrier, either amplitude characteristic, frequency characteristic or phase characteristic of the carrier will change in accordance with the amplitude variation of the input. Proses modulation ini akan mengubah suai sifat carrier. Okay, akan mengubah suai sifat carrier, salah satu daripada sifat carrier, either amplitude, frequency or phase. Okay, so if the amplitude of the carrier change in accordance with the amplitude variation of the input signal, then you will produce AM. AM is this one. Okay, so you see that originally is like this. Carrier originally like this. Then you modulate with the input message. And if the amplitude of the carrier change in accordance with the input, so you see that the amplitude of the carrier, okay, the up and down, okay, the up and down change in accordance with the input. This is what we call as amplitude modulation. Okay, and then what? If the frequency of the carrier change, this one, okay, if the frequency of the carrier change in accordance with the amplitude of the if the frequency of the carrier change in accordance with the amplitude variation of the input, then you will produce frequency modulation signal, which is this one. If the phase of the carrier change in accordance with the amplitude variation of the input signal, then you will produce PM, phase modulation signal, this one. So both FM and PM are related to each other. Okay, the changes, you see that the changes is right and left, the changes in terms of frequency and phase. Okay, you will see the ripple of the waves closer and close to one another, and also berjarak-jarak, and also have a wider ripple like this. So you see that, for example, here and also here, this is a high frequency. When the wave has a high frequency, that means the ripple is close to another. Okay, when the ripple of the wave is wider, that means the frequency becomes smaller. Okay, and there's no change in the amplitude. Okay, the amplitude remains constant. Okay, so you see that the amplitudes from the original carrier like this, the amplitude remains constant, only the frequency and phase will change for the FM and PM. Okay, so you will learn this in chapter 3 later. Okay, modulation. Why we do the modulation process? Why? Okay, so it is extremely difficult to radiate low frequency signals from antenna in the form of electromagnetic energy. So originally the input message has a low frequency. For example, your voice. Okay, we cannot transmit our voice into the medium for a long distance transmission. We need to do the modulation and convert it into electromagnetic waves so that we can transmit in a longer distance. Okay, so it is possibly theoretically but empirically realistic. So you see that C is equal to lambda times F, or you can say that lambda is equal to C over F. Okay, so this is number 1, and this is related to number 2 of reasons. Okay, number 1, we do modulation so that we can transmit into the medium at longer distance. Number 2, this is related to the antenna size. Okay, when we do the modulation, that means we translate low frequency into a higher frequency. And if we change the input frequency into a higher frequency, that means we're gonna have a smaller lambda. A smaller lambda means that we can design the antenna to be smaller. Okay, because antenna dimension is depending on the lambda parameter. The smaller the lambda, the smaller would be the size of antenna. So you see that, for example, like your mobile phone, we are using a high frequency 4G LTE, for example, like this. The frequency is higher than 900 megahertz until 1 gigahertz, for example. So the size of antenna becomes smaller inside the mobile phone. If you look from the older mobile phone which has the antenna outside of it, okay, that one is the older version of antenna system. Okay, now the antenna is very small inside this mobile phone. Okay, and then what? Does the voice signal require very large antenna? Expensive. So if we use a low frequency, we need a bigger antenna. Okay, number 3, what? Number 3 is about, you can say that number 3 is about multiplexing. Okay, because modulation also, we can multiplex many input together. Okay, so for example, like this, you have the transmitter like this, you have the carrier. Okay, and you can have many inputs. We can do the modulation together with the carrier, and we can transmit it as a single output signal. So we can do the multiplexing. Okay, so modulation also can help to do the multiplexing process. Easy for us to do the multiplexing process. and there's another reasons why we need to do the modulation. And if you remember last week also, I told you that modulation is the topic that have been asked to me during the job interview. Okay, so previously, a long time ago, I went to the job interview in the Flextronic. So one of the engineer asked me, explain to me about modulation. What do you understand about modulation? So that's why at that time also difficult for me to explain about this concept. Okay, and after years later, now I understand more understand about this concept. Okay. So basically, when you go to the job interview, they are not going to ask you very high level technical questions. Instead, they will ask you about your understanding about the basic concept, the fundamental concept. How good are you in understanding about the fundamental concept? They are not going to ask you very technical. Okay, they're going to ask you very simple fundamental issue. Do you understand this? How far is your understanding? Okay. And then what? Information signal often occupy the same frequency band, and if the signal two or more sources are transmitted at the same time, would interfere with each other. So this is we can get. Okay, so this is we can say number 4. Why we need to do the modulation? Because we want to avoid interference. Okay, we want to avoid interference. Okay, avoid interference. So why we can avoid interference? Because there are more spaces at higher frequency compared to the lower frequency. So many channels can be formed to carry many simultaneous communication without the interference. Okay, so this is for the number 4 reasons why we need to do the modulation process. Okay, so previously we also have asked the students in the exam, explain about the modulation, define the modulation, and why do we need the modulation process. So you can explain. There are at least 4. In this slide there are 4 reasons. If you read the books, there are many other reasons. Okay. Multiplexing. So multiplexing is a process of combining many input to share a single medium, single channel. Okay, for example, here we do the multiplexing. We have the n inputs, we combine it together, we transmit it across a single channel, and then after receiving at the receiver, it will be demultiplexing. Okay, we demux, and then we produce the same n outputs. Okay, so multiplexing is the process of combining. We send together all the combined signal across the medium, and then at the receiver side we need to demultiplex the combined signal into different outputs. Okay, so multiplexing and demultiplexing is common in the practical system. Of course, in the practical system, we are using a high-level multiplexing techniques to combine many signals together. Okay, so if you see that, even for the mobile communications, okay, at the base station, for example, so the base station receive many signals, okay, and transfer it into another base station at longer distance. So multiplexing is a must. It will be done in the communication system. Okay, this is done in order to save the bandwidth requirements. Okay, because in the practical cases, the bandwidth is limited. For example, like the mobile communication, the bandwidth for each of the telcos, for example, like Maxis, DG, Celcom, so all of them has a very small bandwidth which need to be shared with millions of users. So they need to accommodate the bandwidth precisely to cater all the users. So they need to do the efficient multiplexing process so that they can support many users. Many users means a lot of money. Okay, you need many users to generate a lot of money. Okay, so if you can manage the bandwidth, you have a small bandwidth, you can accommodate many users, then you can have a lot of money, income. Okay, that one is for the telco's perspective. Okay, so what are the type of modulation techniques? So there are many. What are the multiplexing techniques available? So there are many multiplexing process available in the practical system. Okay, ada banyak jenis proses multiplexing. Okay, so the oldest one is what we call as a frequency division multiplexing. Multiple signals share common bandwidth of a single communication channel. So that means you have a big bandwidth, you cut the bandwidth according to the frequencies. So this is what we call as a frequency division multiplexing. Useful bandwidth of medium axis require bandwidth, so each signal occupies a separate portion of the bandwidth. So you're going to see the picture later. So each signal modulates a different subcarrier frequencies. Okay, subcarriers are linearly mixed to a form of composite signal that is usually to modulate a final carrier for the transmission. So this is involved many carriers and many input. Okay, carriers frequencies separate so that signal do not overlap or guardband. Channel allocate even if there's no data. So this is among the disadvantages. So how does it looks like? Okay, so you see that here we have the frequency band. Okay, frequency band here. This one. Okay. So this is the frequency band, the whole bandwidth. You see that the whole bandwidth. So the whole bandwidth, this one. So this is frequency in terms of hertz. Okay, and all of this is the bandwidth. All of this is the bandwidth. Okay, so the bandwidth is divided into different frequency band. Frequency band 1, frequency band 2, 3 and so on. So previously we draw like this. Sebelum ni kita lukis seperti ini. Previously we draw like this in the bandwidth slides. If you remember in the bandwidth slide, we draw the bandwidth like this. So imagine that each of these is allocate for different frequency band, different channel. So for example, frequency band 1 for radio channel 1, frequency band 2 for radio channel 3, channel 2, channel 3 and so on. For example, this is for example Hot FM, this is for Surya FM, this is for Era FM and another radio stations. So you see that the bandwidth are divided into different set of frequencies, and each of the frequency band are separated by what we call as a guard band. Okay, so the guard band here separate the frequency band. It is empty spaces where the signal should not operate, where the radio station should not operate within this guard band. So the guard band is actually to separate different frequency channels and to avoid interference. Okay, this is for the FDM, frequency division multiplexing. And for your information, this FDM is used in the first generation of telephone system. Ni first G, first G use this technique, first generation. Okay, this is FDM is the term used for the multiplexing in the wired transmission. And if you use in the wireless transmission for example like the mobile communication, they use the term what they call as the FDMA, frequency division multiple access. So this is for the wireless. Okay, FDM is a wired telephone system. Okay, and if you see from here, you see that if we divide the frequency, that means radio station 1, radio station 2, radio station 3. That means each radio station can use the same frequency in all time. Okay, pada bila-bila masa. Even though the radio station does not transmit any signal. So you are actually giving the frequency to the user, although the user did not use the frequency at that specific time. So there's a waste. Sometimes this can also mean that it's a waste. You're wasting the bandwidth. You are giving the frequency to users, even though the user does not use it at a particular time. Okay, so this is about FDM. FDM means that you divide the frequency, and that user, that radio channel can use the frequency band at any time. So this is for the first generation of communication. And then what? The second generation. This is the second generation, or 2G. Okay, so second generation, we divide the time. Instead of dividing the frequency, we divide the time. So you see that. So here is the y-axis is the frequency. Okay, the horizontal axis is the time. Okay, so you see that the bandwidth. Okay, the bandwidth is from above until below. So instead of dividing the bandwidth, we are actually dividing the time into a different time slot. Okay, so users can take the time slot whenever they want to send the signal. Okay, and the user needs to will take the time slot whenever they want to send the signal. So means that you are not giving the frequency, instead you are giving the time slot for the user to transmit at a particular time. And each time slot is separated by guard time. Okay, and the beauty of this is that you can use the entire bandwidth. Okay, you see that you can use the entire bandwidth, but only for a short period of time. Okay, you can use the whole bandwidth. Okay, the whole bandwidth, but only at a limited time. Nampak eh? So what's the good about this? If you can use the whole bandwidth, that means you can transmit at a faster speed, because bandwidth and speed here is the data rate, speed of transmission. Bandwidth is proportional to the data rate. The higher the bandwidth, the higher would be the data rate. So if you can use the whole bandwidth, wider bandwidth, that means you can transmit at a faster transmission, more quick transmission, high data rate. Now that's a good thing about TDM. Okay, time division multiplexing. That means you are able to use the entire bandwidth, but only for a limited time. And each time is separated by guard time in order to avoid interference with adjacent time slot. Okay, so also this is for the second generation of telephone system. Okay, this is for the second generation of telephone system. But for the wireless communication, we use what we call as a TDMA, time division multiple access. So time division multiple access is used for the mobile communication, wireless communications. This is for the 2G. Okay. Okay, so 2G use a TDMA. And then what? For 3G, 3G is not in this notes. 3G tidak masuk dalam notes ini. Where 3G we have another domain, what we call as a code. Okay, 3G use the CDMA. Okay, CDMA technology, code division multiple access. Okay, instead of frequency and time, we have the third domain, third axis, what we call as a code. Okay, this is for the 3G. 4G use the 4G use the LTE, wide CDMA, WCDMA. So 4G also use the base of coding also, but different, wideband CDMA. 5G are different, another different modulation techniques. Okay, different multiplexing techniques for the higher generations. Now we are moving towards 6G. Okay, so 6G now currently is the deployment phase for the 5G. 5G sedang dalam proses deployment in our country. Okay, and it takes some time because there's some issues with the 5G deployment in Malaysia. Mainly because the frequency band is overlapping with the fixed satellite frequency. So that's the issue in Malaysia. That's why the 5G is quite late to be deployed in Malaysia, because we have a lot of interference issues in Malaysia. Okay, interference from different frequency applications. Okay, that one is 5G. And then 6G is expected to be deployed by 2030. 6G will be combined with the AI, the rise of the artificial intelligence. Okay, that one is another issue. Okay, so the higher the generations, one of the things is that the speed of transmission will becomes faster. That's one thing. Okay, of course speed will becomes faster. There's also many other benefit. Okay. Okay, so now starting from this slide involve calculation. So starting from here, I think you will be happy because we will do a lot of calculation. So you can start hold your calculator starting from this slide. So harapnya tidak boring starting daripada sini. Okay, so before we proceed, can I have your response? Can you hear my voice? You are still there? Any student can respond?
Yes, doctor.
Okay, thank you for the response. Okay, so hopefully after this you will not feel tired, you will not feel boring, because we will do a lot of calculation. Okay, harapnya lepas ini after this it's not theoretical concept. After this is more on the calculation. Okay, so gain in your syllabus mainly involve about the amplifier system. This one, amplifier. This one, this is what we call as this is the symbol of the amplifier, the triangle shape like this. The triangle shape like this. So we have input and we have the output. How do we measure the gain? We divide the output over the input. Okay, kita bahagi output dengan input. So we divide, for example, like this. We have an input voltage, we have the output voltage. So we divide the V out over V in. And you see that in your syllabus we use the symbol we use the symbol of A, parameter A. to define the gain. Okay, A for the gain. Okay, and if you see other literature books, okay, sometimes they will use G for the gain. Okay, so in Wayne Thomas's book, our textbook, it used A for the gain. Okay, but never mind, if you want to use G is also okay, no problem. Okay, tidak ada masalah jika gain itu ingin menggunakan huruf G, no problem. Okay, so you see that the value of gain, output over input, V out over V in, so this value will produce a value larger than 1. Okay, if the value is larger than 1, this is what we call as gain, means that the output is larger than the input. If the output is smaller than the input, we are not calling it as a gain. Instead, we are calling it as attenuation. Okay, gain bermakna output mestilah lebih besar daripada input, sebab dia gain, bertambah. Okay, increased. Okay, so you see that here, for example, we have a cascaded amplifiers. We have 3 amplifiers, 1, 2, and 3. Okay, so in the exams, we commonly ask questions up to 3 amplifiers cascaded. Cascaded means it is connected in series like this. Okay, cascaded means it is connected in series like this. Okay, so we use the word cascaded. Okay, cascaded means combination of amplifiers. So you see that here, amplifiers here, we have the input, we have each of these amplifier has gain, for example 5, 3, and also 4. And when we have this kind of cascaded amplifiers, the way we want to calculate the total gains, A total, is by multiplying all the gains. 5 multiplied with 3 multiplied with 4, so we get 60. Okay, so this is the way we do the calculation for the total gain. How to find the total gain is by multiplying all the gain, okay, all the gain values, then we can get the total gains. Remember, this is the value of the gain is a absolute value gain. Dalam konteks ini, it is in term of absolute value, there's no unit, because it is a ratio of voltage. Okay, and you see that A is equal to V out over V in. Okay, so if I want to find a V out, that means I must multiply A, the gain, multiplied with the V in. Okay, and in this example, so in this example, we have the total gain. Okay, this example, total gain multiplied with the input. So in this case, 60 multiplied with the input here is 1 milli. So 1 millivolt. So we get 60 millivolt. So that's why you get 60 over here. Okay, if you want to calculate one by one, also can. Okay, you can also calculate one by one. For example, 5 multiplied with V in, you get 5 multiplied with 1 milli, you get 5 milli. Okay, 3 multiplied with 5 milli, you will get 15. 4 multiplied with 15 milli, you will get 60 millivolt. Okay, you can calculate one by one, or you can calculate all together. Okay, so most amplifiers are power amplifiers. The same procedure can be used to calculate the power gain. The power can also the gain can also in term of can also be calculated in term of power. That means this is supposed to be subscript. So it is supposed to be A, something like that, subscript P, P out divide with P in. Okay, small okay. Huruf out, perkataan out, this out and in should be the subscript, small letter. Okay. Example. Okay. So example 1.1, what is the gain of an amplifier that produced the output 750 millivolt for a 30 microvolt of input? So you have the amplifier. Okay, so my suggestion to all of you, if you get this kind of question without any picture, so I suggest you to draw a picture of your own. Okay, to draw the picture on your own about this in order to imagine what the question looks like. Okay, saya cadangkan kamu lukis untuk menggambarkan apa yang sebenarnya ditanya dalam soalan. Okay, for example, this is about the amplifier, so just draw an amplifier. Okay, you are given the input you are given the output. Okay, the out is equal to 750 millivolt, and then the input is 30 micro. So the question asks, how much is the gain of the amplifier? How much is the gain? So the gain is equal to V out over V in, okay, which is equal to 750 milli divide with 30 micro. So use your calculator. 750 milli divide with 30 micro, so 25,000. Betul kalau saya salah tolong betulkan So 25,000. Okay, so I get 75,000. So for you, I suggest you to calculate also using your calculator. Sometimes I calculate the value, I give the wrong answer. Okay, sometimes I give the wrong answer due to my mistakes. Sometimes I accidentally key in the wrong value and then produce the wrong answer. So you need to help me to check the answer as well. Okay. So so if you have question, please ask me question. Okay, if you have question, please ask. Okay. And then what? Example 1.2, the power output of an amplifier is 6 watt. The power gain is 80. What is the input power? So you see that here you have again the picture of amplifier. Okay, the output power, P out is equal to 6 watt. The power gain, okay, so you can just put A or AP, is up to you, no problem or you want to put G, no problem. Okay, so in your notes, okay, it is we just use A parameter. Okay, we don't need to put AP, AV or what. So but the good practice is to put AP. This is to show that this is the power gain. Okay, even if you put A, we know that this is about gain. Okay, no problem. Okay, so now the question asks, what is the input power? Okay, what is the input power? So therefore, input power is equal to output power divide with power gain. Okay, so 6 divide with 80. So how much is this? So 6 divide with 80, so you get 0.075, or you can say that 75 milliwatt. Okay, 75 milliwatt. Okay, so if you have question, please ask, otherwise I will move to the next example. Kalau ada soalan terus tanya Okay, example 1.3. Okay, so there are three cascaded, means that there are three amplifiers connected in series. Okay, so you can draw like this. Okay, amplifier 1, amplifier 2, and then amplifier 3. Okay, and you see that the power gains are 5, 2, and 17. AP1, 5, AP2, 2, AP3, 17. The input power is 40 milli, so P in is equal to 40 milliwatt. What is the output power? How much is P out? How much? So in order to do this, again my suggestion, find the total gain. Okay, find the total gain. So the total gain, okay, so the total gain A total is equal to AP1 times AP2 times AP3. Okay, AP3. So this is equal to 5 multiplied with 2 multiplied with 17. So how much is this? 5 times 2 times 17. So you will get 170. Okay, and then what? P out is equal to A total multiplied with the P input. Okay, so 170 multiplied with 40 milliwatt. 40 milliwatt. So it is equal to times 40 milli. So you get 6.8. So 6.8 watt. Okay. If you have question, please ask questions. I can explain to you about this. Okay, so I suggest you, to all of you, make sure you highlight the final answer. Okay, make sure you highlight the final answer. Either you want to use a line like this. Sometimes the student like to do like this, hashtag, okay, or whatever thing that you can highlight the final answer, or you want to circle the final answer, is up to you. Okay, why I ask like this, I ask you to do like this, because during the final exam, sometimes it is difficult for me to find your final answer, to find the student's final answer. Sometimes it is at the bottom of the page, sometimes above the page, sometimes on the right, sometimes on the left. So which one is the final answer? So I need to know your final answer, so that easy for me to give you marks. Okay, so please make sure that you highlight the final answer. How you want to highlight is up to you. Okay, so if you don't have question, I will move to the next topic. Okay, attenuation. Attenuation means degradation of signal energy. Okay, attenuation bermaksud perlemahan signal. Okay, so attenuation, if you see from here, attenuation A, also use the symbol A. So no problem. In the previous, in other literature books, they use A for attenuation and G for the gain. But for the Wayne Thomas's book, they use the same symbol A for both gain and attenuation. So no problem. So if you see that here, attenuation means degradation of signal energy. That means the output is less than the input. So what you will see later, that this ratio will produce a value less than 1. Okay, if the value less than 1, we call it as attenuation. Okay, If the value is more than 1, we call it as a gain. Okay. And for the cascaded circuit, of course, we can find attenuation total by multiplying all the attenuations. A1 multiplied, A2 multiplied with A3. Okay. Voltage divider network may introduce the attenuation. Okay, this is example, which is the voltage divider, like this. Okay, so this voltage divider, you see that here we have the input. Okay, the input, and then connected to two resistor connected in series. Okay, R1 and R2. Okay, so in the middle here is connected to the V out. Of course, if you know the circuitry, this one is also to the ground, connected to the ground as well. Similar with this one, also connected to the ground. Okay, this is a full, if for the full circuit. This is not a full circuit. So if you see that here, how to find the V out? V out is equal to V in multiplied with this parameter. Okay. So this parameter is equal to R2 over R1 plus R2. Okay, because we want to measure the V out from this point to the ground. Okay, we want to measure the V out from this point to the ground. Okay, that means we're going to take R2 over R total multiplied with the V in order to find the V out. Okay, so R2 over R total, this is the attenuation parameter. Okay, so you see that R2 divide with R total. R2 is 100, divide with a total of 300, so you get 0.33. 0.33 you multiplied with the V in, then you will get the V out. Okay, so this R2 over R total, this is what we call as the attenuation factor, A parameter. Okay, for example, another example. So attenuation is described as a loss stage. Okay, described as a loss stage. So instead of using a triangle, it uses a square like this, rectangle boxes like this for the loss circuit. And you see that the attenuation parameter is less than 1. You see that A1 0.2, A2 0.9, A3 0.06. So any value less than 1, this is categorized as attenuation. Later you're going to see example of combination loss stage and amplifier stage. Boleh juga kalau kita gabung, we can combine it actually, loss stage and also the amplification. That means we have the loss, we have the attenuation, we also have the gain. And the way we calculate the total is also the same. Multiply it all together. Sama juga kalau kita ada gabungan loss stage dan juga amplifier. Cara untuk mencari A total, we need to multiply all of it. Okay, so let's look in this example. So the total attenuation is equal to A1 multiplied A2 multiplied with A3. When you multiply all together, 0.2 multiplied 0.9 multiplied with 0.06, so you will get 0.0108. So this multiplied with the input voltage. If you multiplied with the input voltage, you will get the output voltage. A total multiplied with V in, so you get 0.0324, which is equal to 32.4 millivolt. So you can try, multiply this one, 0.0108 multiplied with 3 volt. So you will get this 32.4 millivolt. Okay. And then what? So if you have question about this, please ask me about this. Kalau ada soalan, sila tanya. Okay. If you don't have question, I will move to the offset, this topic. So attenuation can be offset by introducing gain. Offset here means that we want to produce A equal to 1. Okay, offset means that we want to produce A equal to 1. That means output equal to the input. So how to do the offset? How to do the offset? So if you want to offset the attenuation, that means you need to introduce additional gain so that you can do the offset. For example, like the voltage divider like this. So previously, when we want to find the the output, so the output is from this point until the ground, until the ground. So if you want to find the A parameter over here, that means 250 ohm divided with the total resistance. Okay, so 250 divided with the total resistance, so you get 250 over 1000, so you get 0.25. This is the attenuations. Now the issue is, how can we offset this value? Macam mana nak offset this value? How to make this A becomes 1? In order to do this, we need to introduce amplifier A2. Okay, and how much is A2? How much gain that we need in order to make the A parameter becomes 1? So what you can do is you need additional to it. That means you need you introduce another gain A2, right? So you want to make it as 1. So that means like this, A total is equal to A1 multiplied with A2. Okay, you want to make it as 1, that means A1 is 0.25 multiplied with A2. So A2 is equal to 1 over 0.25, which is equal to 4. That means you need an amplifier which has a gain equal to 4, so that you can offset the parameter A. Okay, so you see that here it uses the amplifier with the gain of equal to 4. So you can offset the output. You can make it A equal to 1, V out equal to V in. Okay, and you see here A total is equal to A1 multiplied with A2. So 0.25 multiplied with 4, you will get equal to 1. So if you get 1, that means you manage to offset the parameter of A. Nampak You offset attenuation by introducing additional gain. What if we want to offset the gain? If we want reverse, if the reverse process, if we want to offset the gain, that means we need to introduce attenuation. For this case, we want to offset the attenuation work, so we introduce additional gain for this example. Okay. So if you have question, please ask. Otherwise, I will move to the next topic. This one. So this is the example of combination, loss stage, and also the gain. Okay. Ada yang nak tanya soalan ke?
Saya, Doktor.
Ya, silakan.
Doktor, why we need to do the offset?
Why we need to do the offset?
Yeah.
Okay, the reason is that we want to know how much is the gain that we need to introduce in the system, so that we can eliminate the attenuations, because attenuations means that reduction in signal energy. So when the signal is reduced in terms of energy, that means we need additional gain so that we can increase the energy of the signal. So that's why the word offset here means that we want to know how much additional gain that we need so that we can do the improvement. So if you ask me why we need to do this, this is for the purpose of improvement. Okay.
Okay, got it.
Okay.
Thank you.
Okay, the next topic. Okay. So if you have question, please ask. So pelajar yang bertanya, bagus you tidak, don't be passive. Jangan passive. Our class is relax. Santai. Kelas ini santai. You are most welcome to ask question anytime. Okay. Okay. About this example. This example is combination. Lost stage. We have the gain. We have the lost stage. We have the gain again. Okay. So now the issue is how to find the A total. So when you have this kind of system, you don't know whether the output is actually a gain or the attenuation. So first of all, you need to find the A total. Okay, find the A total is by multiplying all the A parameters. A1 multiplied A2 multiplied A3 multiplied A4. Regardless whether this is a gain or attenuation. Okay, tak kira sama ada dia gain atau attenuation, we can multiply all together. Okay, so for example here we want to find the A total. A total here is A1 multiplied A2 multiplied A3 multiplied A4. 0.1 multiplied with 10 multiplied with 0.3 multiplied with 15, so you get 4.5. So you see that the value is more than 1. That means the result at the output is actually a gain. That means I can expect that the output is larger than the input. Okay. If the value here is less than 1, that means what I can expect the output less than the input. So if you analyze from here, 4.5, if you multiplied with a V in, you will get 6.75. Okay, you can use your calculator, multiply both of these, you will get 6.75. Okay, and if you want to go one by one, you see that 0.1 multiplied with 1.5, you get so you get 15. Okay. So sorry, this is 0.15. So this is not 15 as 0.15. Okay. So 0.1 multiplied with 1.5, so 0.15. Okay. And then 0.15 multiplied with 10, so you get 1.5. Okay. 0.3 multiplied with 1.5, you get 0.45. 15 multiplied with 0.45, you will get 6.75. This is if you go one by one. Okay. So this is about the combination. So no problem, you can multiply all together. Okay. The next example. The next example. Okay, the next example, 1.4, a voltage divider shown in figure 1.7 has the value of R1 equal to 10 kilo ohm, R2 equal to 47 kilo ohm. What is the attenuation? Figure 1.7, like this one. Figure like this. So you have the we have the voltage divider with R1 and R2. But now you are given R1 and R2. Okay, you are given R1 and R2. So here, for example, here is V in. Okay, you have R1. So again, when you have this kind of question, I suggest you to draw on your own. Okay. So sila lukis for you so that you are easy to understand the question. Okay. Okay. So this is R1. This is R2. Okay. So this is R1 is 10 kilo ohm. This is 47 kilo ohm. So how much is the attenuation? Attenuation is equal to 47k. 47 divide with 47 plus 10. So this is in term of kilo ohm. In term of kilo ohm. Okay. So this is around, sorry, this is kilo ohm, this is kilo ohm. Okay, kilo ohm, no unit. So you get how much? 47 divide with 0.8 47 divide with 57, so you get 0.8 0.82. Okay, around this one. Okay, 0.8256. Okay, so you can if you ask me, okay, if you ask me, I would suggest you to make up to 3 decimal point. Kalau tanya saya lebih mencadangkan pelajar up to 3 decimal point. That means like this. Okay, in the exam, better for you to do up to 3 decimal point. Of course, later you're gonna see in the example, sometimes in the example in your notes they will rounded up the value. Okay, sometimes dalam nota dia akan bundarkan contoh for example 0.98. Sometimes in your notes will rounded up the value into as a 1, equal to 1, for example. Okay, so in example normally sometimes it rounded up the value so that easy for the student to understand. Okay, but in the exam I would suggest you to make at least up to 3 decimal point. Okay, that's my suggestion. And then what amplifier gain would you need to offset the loss for an overall gain of 1? So now the issue is, how can I offset this value? Okay, how can I offset this value? Okay, so in order to do this, I need to introduce a gain. So that means I need to introduce an amplifier with gain of A2. How much? Okay, how much is A2? So that means A total, so this is become A1. Okay, so A1 is here. Okay, so therefore A total is equal to A1 multiplied with A2 equal to 1. So in order to find A2, this is equal to 1 over A1. So this is 1 over 0.825. Okay. So I need amplifier with a gain of 1.212 in order to offset it. Okay, I need amplifier equal to 1.212 so that I can offset the attenuation. Okay, so do you have question to ask? If you don't have questions, I will move to the next example. Ada soalan nak tanya, boleh tanya. Otherwise, I will move to the next example. So this is an easy example, straightforward. Okay. So this example is actually based on this one. Based on this one. Example 1.5. And then after this one, okay. Example 1.5. An amplifier has a gain of 45,000, which is too much for the amplification. Okay, so you are given an amplifier which has a A equal to 45,000. and it is said that this is too much for the amplification with an input voltage of 20 microvolt. So V in is equal to 20 microvolt. What attenuation factor is needed? What attenuation factor is needed to keep the output voltage from exceeding 100 millivolt? So that means the question said that we have another loss stage. We have another loss stage. Okay, with A2, this one is A1. How much is this? So that the output is not exceeding. That means less. So that means the V out. So that means the V out. Wait, So that means the V out is less or equal to 100 millivolt. Okay. So now what you can do is okay. So what you can do is that find the A total. Okay. So A total is equal to A1 multiplied with A2. Okay, so this is equal to 45,000 multiplied with A2. Okay, so 45,000 of A2. Okay, and then what? The output. Now the output, we can use the upper bound of the output. Okay, that means V out is equal to A total multiplied with the V input. Okay, so let's say I want to use the upper bound because the maximum is 100. Okay, we cannot make it more than 100 because we want to maintain the output to be 100 millivolt or less. Okay, so for example, I use the upper bound, the upper limit, okay, 100 millivolt equal to A total multiplied with VI. So this is equal to A total is 45,000 A2 multiplied with V input is 20 millivolt. Okay, so just multiplied 45,000 multiplied with 20 micro. So this is micro, right? Okay, 20 micro. Okay, so you get 0.5, sorry, 0.9. Okay, okay, before that. So this is not a good idea. Wait. Okay, sorry, this is not a good mathematics way, so I will show you later. Wait. Okay, in order to avoid confusing, so let's do like this. Okay, like this. So A total is actually equal to V out over V in. Okay, so since we have V out is 45,000 A2, this is equal to, so the V out here I need to use a value, but what value should I use? Because the range is up to 100 milli. So what I can do is I can use the upper bound, the upper limit, which is 100 millivolt, and then divide with the input here. V in is equal to 20 micro. Okay, so this is how much? 100 milli divide with 20 micro. So 5,000. Okay, so therefore A2 is equal to 5,000 divided with 45,000. Okay, so I get 0.111. Okay, (0.111). Okay, so this is the attenuations that I need. Okay, that means this is the minimum attenuation. Okay, minimum attenuation. That means the value of A2 must be equal or more than 0.11, so that I can keep the output to be equal or less than 100 millivolt. Nampak So you see that the value of A2, sorry, I said minimum. It's actually the in terms of magnitude, this is the minimum. Okay, what I mean is that the attenuations needs to be larger, or means that in terms of magnitude needs to be smaller. Okay, so if you ask in terms of magnitudes, that means that A2 needs to be 0.111 or smaller than this in terms of magnitude, so that we can keep the output less than 100 millivolt. Okay, because if you put 0.15, for example, you will produce output more than 100 milli. Okay, that means the value of A2 needs to be smaller than this, so that we can keep the output less than 100 millivolt. Okay, so the answer is 0.111. Okay, this is the answer. Okay, we can take the upper bound, no problem. Okay, we can take the upper bound value. That means A2 is equal to 0.111. Okay, ada soalan? If you have question, please ask. Otherwise, we will move to the next topic. Kalau ada soalan, boleh tanya. If there's no question, let's look into the next topic. Okay, decibel gain. Decibel gain. So gain can be expressed in terms of decibel. You see that? I think you know about dB. You always heard the terms dB, dB, dB. So dB means decibel. Okay, so remember that when you get the gain, remember gain A is equal to V out over V in, for example. You get a value, okay, you get a value of which is a unitless parameter. Okay, because when you do the ratios, when you divide, you get a value without a unit. Nampak the gain and also the attenuation is a parameter. Both gain and attenuation are the parameters without a unit. They are unitless parameters because it is a ratio. Okay, gain dan juga attenuation adalah parameter yang tidak mempunyai unit kerana dia adalah hasil nisbah, hasil bahagi. Okay, ia adalah nisbah. It is a ratio because of the division process of the same parameter, voltage over voltage, power over power. Okay, and we can convert this unitless parameter into decibel, which is dB. So how to convert? That means 10 log of 10. 10 log of the value. Okay, absolute value here means that the gain or the attenuation which has no unit, absolute value. Okay, so 10 log, for example, 10 log 100, okay, or 10 log 0.1. So you get the value in terms of dB. And the good thing about decibel is that you can see whether this is a gain or loss based on the sign parameter in front of the value. For example, for the gain here, for example, the gain is equal to 2. In decibel, 10 log 2 equal to 3 dB. So you see that 10 log 2, how much? Yeah. So 10 log 2, you get 3.010299. So it has been rounded up to 3 dB. So you see that in your notes, normally they rounded up the value so that easy for you to understand. Okay. So you see that this is a positive. What about if we change into decibel for an attenuation values? Okay, attenuation 0.5 change to decibel, so that means 10 log 0.5, so you get minus 3 dB. So the sign minus here means losses. So we know that this is related to the attenuation. So logarithmic nature of dB large range in absolute value is compressed. So what is the good thing about using a decibel? The good thing is that we can represent a larger value, larger absolute value into a smaller decibel value. And we can also express smaller absolute values into a bigger decibel value. Nampak? So in this case, decibel makes us easy to do the calculation. Okay, so nombor yang besar dalam absolute value boleh ditukar kepada nombor yang lebih kecil dalam decibel, atau nombor yang kecil dalam absolute value boleh ditukar kepada nombor yang lebih besar dalam decibel. Okay, so that why we do the decibel process, so that easy for us to do the calculation. Okay, so gain and attenuation loss are expressed in decibel rather than the absolute value. Normally, most of the time, in practical cases, we express the gain, the attenuation in terms of decibel. Okay, normally we use decibel. Using decibel, total gain or attenuation can be calculated by simply adding the gains and the attenuation expressed in terms of decibel. So you see that the last sentence over here, when we convert into decibel, we can change the multiplication process into summation process. Remember in the previous slides, you calculate the A total equal to A1 multiplied with A2. So you multiplied absolute value. Okay, but now once we have converted into decibel, so A total in decibel can be calculated as A1 in decibel plus A2 in decibel. You see that? Okay. So you see that if you convert both of these, if you convert into decibel, if you convert A2 into decibel, then when you want to find A total, you just need to do the summation process. You will see the example later. Okay, kamu akan nampak example ini kemudian. Okay, though this is the decibel makes us easy to do the mathematical process, mathematical calculation. Okay. Next, decibel power. Decibel power in terms of decibel. So when we want to convert power into decibel, normally there's gonna be a slightly different in terms of the symbol. For decibel, we can use the dB watt, dB milliwatt, or dB microwatt. So you see that you want to convert power in terms of watt or milliwatt or microwatt, for example. So you want to convert it into decibel, so it becomes dBW, dB milliwatt, dB microwatt, and so on. So what's the difference? What's the difference? Previously is gain or attenuation. Gain or attenuation are the parameters that has no unit. It's a unitless parameter. Different from the power. Power has a unit. The unit is in terms of watt. Nampak Okay. So if you want to see the difference again, I will show you the difference. What is the difference between 10 watt and 10? Apa beza dia? Both are 10. So this is the parameter of this is a unitless parameter. This is a unit parameter. The unit is watt. Okay. So when I want to convert this one, so 10 log 10 watt. Okay. So 10 log 10, so this will become 10 dBW. Okay. If I want to convert this, that means 10 log 10, so I will get 10. Okay. 10 what? 10 dB. Okay. So that's the difference. Okay. So dB is the representative of values without a unit. So decibel dB adalah untuk parameter yang tidak mempunyai unit. When you convert into decibel, it becomes dB. But different from the power. Power has a unit, 10 watt, for example. So 10 log 10 watt, so you get 10 dB, but this is dBW. Okay, so that's the difference. So let's look into a few examples like this one. So dBm and dBW are the decibel units used to express power in the communication. For dBm, the reference level denominator is 1 milliwatt. Okay, we're going to see later about this. Okay, so you see that here, for example, let's go from here, from 1000 milliwatt. 1000 milliwatt is equal to 1 watt. So you want to convert into dBW. So what you can do is 10 log 1 watt of power divide with the reference value 1 watt, and you will produce 0 dBW. So the reference value here is depending whether you want to produce dBW or dBm or dB micro. Okay, so since I want to produce a dBW, that means the reference value is equal to 1. Okay, equal to 1. Okay, another example, the second one. Okay, so we go from below to up. Okay, so 1000 milliwatt. Okay, I want to convert it into dBm. Okay, so what I need to do is, remember that M here means milli. Sorry, no, this one. Yeah, wait. So remember, M here means milliwatt. Okay, so what I need to do is 10 log of power, this one, 10 log of 1000 milli divide with the reference 1 milli. Why divide with 1 milli? Because I want to produce dBm. Okay, if let's say I want to produce a dB micro, katalah saya nak let's say I want to produce dB micro. So what I need to do is I will divide with 1 micro. So that means 10 log base 10 1000 milli divide with 1 micro. So I will produce dB micro. Okay, dB micro. So how much? So 1000 milli divide with 1 micro. So that means 10 log. So I will get how much? How much you get? I get 60 dB micro. Kalau saya nak tukar kepada dB micro, if I want to change this into dB micro, that means this is going to be 60 dB micro. Okay. Another example here. Ni kalau ada soalan boleh tanya. Okay. So you see that what we want to produce, you need to the unit that we want to produce will determine the value of the reference value. Okay, the reference value is the denominator of this division process. Okay, bahagian pembawah. Kalau saya nak hasilkan dBW, that means my reference value would be 1. If I want to produce dBm, my reference would be 1 milli. If I want to produce dB micro, my reference value would be 1 micro, and so on. Okay. Another example, this one. 1 milliwatt, we want to produce dBm. So dBm here means that the reference would be 1 milli. So 1 milli divided with 1 milli, so I get 1. So 10 log 1, you will get 0. But the unit is dBm. Okay. So now you see what are the difference between dBW. dBW we divide with reference 1. dB milli we divide with the reference 1 milli. dB micro we divide the reference value of 1 micro. So that's how we calculate the decibel. Okay. Okay, if you don't have question, let's go to the example. Maybe you can understand from here. Okay, so this is the conversions of milliwatt into dBm into dBW. Okay, remember this is milliwatt. Okay, so for example here, okay, so this is I take this example. So this is actually 0.01 milliwatt, 0.01 milliwatt. So let's do the example. 0.01 milliwatt. Okay, so I want to convert it into dBm. For example, I want to convert into dBm. That means I need to do 10 log 0.01 milliwatt. So I need to divide with the reference value. So since I want to produce dBm, so I will divide with 1 milliwatt. Okay, so therefore I will produce how much? So milli and milli. Okay, so 10 log 0.01, so I will get negative 20 dBm. Okay, what about if I want to find the value in terms of dBW? If I want to find the value in terms of dBW, that means I need to divide with the value of 1 watt. Okay, 1. So therefore, 10 log 0.01 milli. So you get here negative 50 dBW. Okay, ni boleh try negative so ni negative. Okay, and then what? Let's try a second example. 0.1 milli. Again, this is 0.1. So 0.1. So here, let's try here 0.1. This one is let's do the calculation here. So 10 log 10 log 0.1 milli divide with for example we want to find dBm, so we divide with 1 milli. Okay, so we get here 0.1 so 10 log 0.1, you get minus 10, so you get minus 10. Okay, if you want to find in terms of dBW, 10 log 0.1 milliwatt divided with 1 watt, so you get here okay, so 10 log 0.1 milli, so you get minus 40. Okay, so this is minus 40. Okay, and what about this one? Let's go the last one. So this is, for example, 10 log 1000 milli divided with 1 milliwatt, for example. So this is 10 log 1000, so you get 30 dBm. Okay, 30 dBm. If you want to find in terms of dBW, so that means 10 log 1000 milliwatt divided with 1 watt, so this is equal to okay, so 10 log 1000 milli, so you get 0. Okay, 0 dBW. If you already get used to this kind of conversion, so it's easy for you to change between dBm and dBW. So you see the difference. The difference is 30. Okay, minus 20 dBm convert into dBW, you minus with 30, so you get minus 50. Minus 10 convert to dBW, you get you need to subtract with another 30, so you get minus 40. And then here 30 minus 30, you get 0. Okay, the rest you can do on your own. Okay, practice on your own. If you have question, please ask question now. Okay, if you don't have question, I will move to the next slide, this one. Okay, power ratio. Okay, power ratio. So decibel, so when we do the power ratio, that means watt divide with watt. So you produce a value without a unit. Okay, you produce a value without a unit, and when you convert into decibel, you will convert it into dB, not dBW, because this is a ratio of power. Okay, so decibel is also used to measure the ratios of gain, attenuation, as S and R. Power ratio in communication is usually expressed in dB. For example, 10 log P1 over P2, so you get in term of decibel. P1 in term of watt divide with watt, so you get a value without a unit. So when you convert into decibel, it will be in term of decibel. For ratios, there's no unit, just dB to tell the value is in term of decibel. Voltage or current ratios can also be expressed in term of decibel. So be careful about this. So let's look from the power. Okay, so for power, as we learned previously about the power decibel, okay, so when you want to convert the power ratio, that means 10 log P out over P in, so you get in terms of decibel. Okay, what about the voltage and current? why suddenly there's 20 over here? Kenapa tiba-tiba ada 20? So this is not a magic number, okay? This is not a magic number. Again, it is based on the Ohm's law, V equal to IR. And also remember about the power. Power is equal to V square over R, or V square over 2R. Okay? And also this is equal to I square R. Remember about that. So if in term of RMS, this is a V RMS square divided with 2. So either one. So that means if you see from this perspective, this is it is actually derived from the power. So you see that here we can this one, okay, from the P out, it is actually equal to I out square R divide with I in square R. Assuming that the resistance is same, okay, assuming that the resistance is same, so it is actually equal to I out over I in square. Okay, so it is actually like this. So 10 log I out I in square. So this square can be bring forward. So that means 20 log I out over I in. So that's why the value 20 comes in. Okay. Similar with V out. Okay. So this is actually 10 log. Okay. So for example, here is V out. So for example, I'm using a peak value over here. So that means V out square over 2R divide with V in square over 2R. Okay. So assuming that the R is the same, resistance is the same, so it is actually equal to V out over V in square. Okay. So it is actually equal to, so I put up here, so 10 log V out over V in square. So this square can be bring forward. So that's why it becomes 20 log VO over V in. Okay. So you get in term of decibel. So be careful in term when you want to calculate the ratios, the decibel for ratios in the exam questions. So you need to see whether this is a voltage ratio or current ratio or power ratio. Okay. Ideally for the power ratio, we can just straightforward do the calculation. But if it is a voltage ratio or the current ratio, when we want to convert into decibel, we need to use 20. Okay, so be careful about this. Okay, because if you see in the exam, sometimes it is used a voltage ratio. So voltage ratio, when you want to change into decibel, you need to use 20 log. If it is a current ratio, then you can use the 10 log. Okay, so be careful in terms of ratios in the exam questions. Okay, so many students confused about both of these. Okay, so what you need to do is you need to see the keyword in the question. What kind of ratio is this? Is this a power ratio? Is this a voltage ratio or current ratio? If voltage and current ratios, that means you need to use 20 log. Or if power, then use 10 log. Okay, just like that. Okay, so if you have question, please ask. Otherwise, I will move to the next topic. Okay, example 1.6. A microphone has an output value of minus 50 dBm. Calculate the actual output power. Okay, so that means you have the microphone. Okay, the output here is P out is actually equal to minus 50 dBm. Okay, so the question is, how much is the power in term of what? Watt or milliwatt or microwatt? That means you need to change into this one. Okay, so now this one, so 50 dBm, so that means 10 log this one 50 dBm minus 50 dBm divide with the reference value. So let's say that I want to use sorry, before that this is wrong, sorry, wait. Okay, so I don't know how much is the power. Okay, P out, so I can P out over reference value. So what I can do is that I can just put remember previously we divide with the reference value with the reference value. Okay, and we get here is equal to minus 50 dBm. Okay, so now the issue is not the issue. Now I want to find how much is this. Okay, so I need to find for example here log let's say I assume this is a x. Okay, I can assume this is as x. Okay, equal to minus 5 dBm. Okay, because I divide with 10. Okay, so x, I put here x is equal to antilog of minus 5. Okay, x is equal to antilog of minus 5, which is equal to minus 5 is equal to so this is okay, x is antilog of minus 5, it is 1 times 10 power of minus 5. Okay, okay. Now the issue is, what is the unit? What is the unit? Okay, so remember, if I want to use milli, okay class, if I want to directly convert dB milli, that means this should be, all the thing inside here should be in term of milli. So what I do now, this is actually equal to milliwatt. Why is it like that? Okay, why is it like that? Because even if you do like this, so P out divide with 1 milli. Okay, this is equal to what they call, this is 1 times 10 power of minus 5. Okay, so this one, if I put it on the right side, so it becomes P out equal to 1 times 10 power of minus 5 milliwatt. Or if you want to make it in terms of watt, it is actually equal to 1 times 10 power of minus 8 watt, because this is minus 3. Minus 3 and minus 5, it becomes minus 8 watt. Okay, so the answer is, it's up to you. You want to make it milliwatt or watt, because the question does not ask you whether this is a milli or milliwatt or watt or microwatt. So you can determine on your own. Okay, so remember, okay, if this is in terms of milliwatt, that means everything inside here will be in terms of milli. So that's why I put x. so that I can determine X as a milliwatt. Okay, when I do the conversions, 1 times 10 power of minus 5, the unit is milli. Okay, because this is a dBm. Okay. Also, if you want to use, to avoid confusing, so since a dBm use reference 1 milli. So you see here, dBm 1 milli. So P0 divide with 1 milli, so we get 1 times 10 power of minus 5. What is the unit? The unit is times 1 milli. So it is a milliwatt. Okay. So that means when you want to convert, it becomes like this. P0 equal to 1 times 10 power of minus 5, the unit milliwatt. If you want to convert into watt, that means 10 power of minus 8 watt. Okay. Is there any question? Kalau ada soalan boleh tanya. So if there's no question, let's look in the last example. This one. Okay, tak ada soalan eh? If you don't have questions, I will move to the next example. Example 1.8. Okay, this one. Okay, so before we proceed, can I get response from you? Are you still there? You can see
yes,
my...
Doctor.
Okay,
Yes,
thank you
Doctor.
for the response.
Yes, Doctor.
Okay. Tak ada yang tidur harap-harap masih segar sebab kita buat pengiraan. So hopefully you are feel happy, as you feel energetic to do the calculation. Okay. This example is a good example that almost similar to the final exam question. Okay, this example. This is a good example to practice for the final exam. Okay, and let's do it. Okay, so for a 3-stage system with an input power P in equal to minus 20 dBm. So P in is given, and power gains of the 3-stage are 13 dB, 16 dB, and minus 6 dB. Determine the output power. Okay, so you are given 3 stages. So I suggest you to draw. Okay, I suggest you to draw. So that means you are given 3 stages. Okay, so given P input is minus 20 dBm. Okay, so A1 is equal to 13, A2 is equal to 16, A3 is equal to minus 6. Okay, and if you see from here, minus 6 is actually what? Minus 6 is actually a lost stage. It doesn't matter if you want to put triangle or rectangular picture. Okay, no problem, tak ada masalah. So since I know this is a minus, so this is actually a lost stage. Okay, so I put rectangular like this. Okay, so determine the output power, determine the PO in terms of dBm and dB in milliwatt. Okay, and for your information, okay, usually in the final exam, sometimes we do like this. For example, we don't use dB for one parameter. So we give you, for example, 13 dB for A1, A2 is equal to 16, A3 is equal to minus 6 dB. Okay. Sometimes we do like that. Not sometimes, normally we do like that. So you see that here, this is not dB, this is absolute value. The rest are in terms of decibel. So what you need to do is, you need to convert into decibel if you want to do calculation in terms of decibel. Okay, so be careful. Okay, so sometimes the student asks, is this in terms of dB or not? Of course, this is not dB. Okay, so biasanya pelajar tanya, ini ada silap ke ni? Ini unitnya apa? Biasa pelajar tanya. So when you see there's no unit, that means it is absolute value. So be careful. Okay, be careful. Okay, so in dBm, okay, in dBm. So remember that when we want to do the dBm, so I will show you the first one. The first one, okay. So when we want to find the P out in term of dBm, remember when we want to find the P out in term of non-decibel, for the non-decibel value, what we do is like this, right? So P out is equal to A total multiplied with P in, right? This is what we learned previously, where A total is the absolute value. P0 and P in will be the same unit in watt or milliwatt or microwatt. Okay, so you see that. So if we want to do in term of decibel, it will become like this. P out. Okay, so P out in term of dBm is equal to A total in term of dB. So since this is plus, so this is multiplication. So multiplication in multiplication process for the absolute value is equivalent to summation process in decibel. That means this one P in term of dBm. So both of these must be the same, dBm. So if this is dBW, that means this is dBW. Okay, so how to find A total? A total in term of dB. So A total, okay, so A total, wait, mana nak buat? So sini So A total in term of dB, we can just add all the gains. Okay, we can just add the gains. Okay, so this is 13 plus 16 dB. Okay, we add up all together. Minus 6. Okay, so this becomes 13 plus 10, so it is 23. Okay, 23 dB. Nampak if this is a katalah, if this is not a decibel, that means you just do like in the previous examples, A1 multiplied A2 multiplied with A3. If it is a absolute value, but now the value given is in term of decibel. If the value given in term of decibel, you should not multiply. Common mistake by the student. Remember, many students, even in the final exam, what they did is they do the multiplication even in term of decibel. So the answer are wrong. Remember kelas, walaupun dalam final exam masih ada pelajar yang melakukan kesilapan dengan mendarab multiply all of this value. That is wrong. If you want to multiply, you need to do anti-log for each of these. Okay? Be careful. If it is dB, decibel, don't do the multiplication. You must do summation. Okay? So, this is 23 dB. Okay? So, you can see that this is 23 plus, this is minus 20. Okay? So you can do the process similarly. Okay? So minus 23 minus so this becomes 23 minus 20. So this becomes 3. But the unit is dBm. Okay? So the unit is dBm. Okay? So dBm, if you want to convert into milliwatt, that means P out is equal to anti-log of so that means this one, so if you want to convert this one, so this is 10 log of power. Okay, power in term of milliwatt is equal to 3 dBm. Okay, so log x is equal to 0.3 dBm. X is equal to anti-log of 0.3. Okay, so anti-log 0.3, 1.995. Okay, so this is equal to 1.99526 watt. Sorry, not watt, milliwatt. Okay, milliwatt. Okay, so X here must be in term of milliwatt. Okay, so X or the power out is equal to milliwatt, 1.995, or you can say that this is 2 milliwatt. Okay, equivalent to 2 milliwatt. Okay, so this is the fastest calculations. Okay, but if you want to do one by one, no problem. Kalau nak buat one by one boleh juga. So if you want to do one by the hardest way is that we do a multiplication process one by one. Okay, for example, we convert minus this one. You need to convert this one first. 13 dB. I don't know whether you already know where is anti-log. Sorry, saya lupa nak tunjuk. In my calculator, I use FX570 MS. So anti-log is, I'm using shift log. Tak ada pelajar tanya tentang anti-log. Semua dah tahu ke? Can anybody respond? Do you know how to do the anti-log? For my calculator, I use shift log. You see the symbol is 10 power of minus x. That is the anti-log. So if I use anti-log 0.3, okay, so I put shift log 0.3, I will get 1.99526. Ada lagi siapa yang tak tahu tentang anti-log? Anybody don't know how to calculate the anti-log? You can respond now. Okay, my calculator I use shift log. Shift log is for anti-log. Okay, shift log is anti-log. Okay, so if I want to convert this one, that means this is 13 dB. Here is anti-log 1.3. I need to divide with 10 first. Divide with 10 and then do the anti-log. So anti-log of 13 dB Okay, I need to divide with 10, and then I do the anti-log, because it is 10 log x equal to 13. So log x is equal to 1.3. So anti-log 1.3, this is equal to 19.9526 at 9526. Okay, this one anti-log 1.6, 39.812. So 39.811. So 810707. Okay, anti-log of minus 0.6, 0.2512, 0.2512. Okay, so if I want to find the total, so A total, that means A total. Okay, so we want to use a different way. Okay, so A total is equal to 19.9526 multiplied 39.8107 multiplied 0.2512. So you get this one is equal to, so you can multiply 19.9526 multiplied with 39.8107 multiplied with 0.2512. So you get 199.5349, 5349. Okay, and this one for the, and if you want to convert the P input is minus 20 dBm. Minus 20 dBm if you do the anti-log. Okay, anti-log, if I straight away convert this one, so anti-log of minus 2, because I need to divide with 10 first, 10 log x equal to minus 20 dBm. So x is equal to anti-log of minus 2. Okay, anti-log of minus 2. So this is equal to anti-log of minus 2. So I get 0.01. 0.01. In term of what? In term of, because this is milli, so I need to put milliwatt. Okay, milliwatt. So milliwatt. Okay. Okay. And if you want to calculate the output power, so let's try this one. Kita cuba. So P out is equal to A total multiplied with P in. So this is equal to 199.5349 multiplied with 0.01 milliwatt. Okay, so 0.01 milliwatt multiplied with 199.5349. So you get 1.99 5349 milliwatt. Sama. So this is similar with this one. Okay, same. Okay, this is the same. Okay. So you see that I show you two different ways. Okay. The first one, we do the summation using a decibel. Okay. From the decibel, we can change into the power by using anti-log. Okay. Previously, we get a 3 dBm, and then we do the anti-log of 3 dBm. So 3 divide with 10 first, then you do the conversion into anti-log. Okay, anti-log 0.3. So you get 1.99526 unit. So unit based on this one. So this is milli, so the unit must be milliwatt. Okay. Okay, so which way you like is up to you. Okay, mana jalan yang kamu suka is up to you. As long as you get 1.99526. Or actually you can also, okay, in the exam if you want to do like this, 2 milliwatt is also correct. Okay, we are not strict about decimal point like this. Kita tidak strict dalam bentuk decimal point. Even though you want to write 2 milli, we still give you the marks because this is 1.999 something. Okay, so don't worry about that. Okay, make sure the unit is correct. You don't put the unit, that means your answer is wrong. Okay, any question? Do you have question to ask?
Doctor.
Yeah, silakan.
For the question for number 1.
Okay.
So dB, if dB plus or minus with dBm is equal to dBm. So let's say
this one, this one.
Yeah. So let's say dB plus or minus with dBW also equal to dBW.
Yeah.
Like that.
So that means like this. For example, we give another example. So that means, for example, I erase this one. Okay. So if this is dBW, that means P in also in term of dBW. Okay. If we change it again, kita tukar lagi. So, okay. If this is for example dB micro, for example, so this one also needs to be dB micro. Okay. So why is it like this? Kenapa macam ni? Why it is like this? Why? So the question is why. So maybe I can show you example. What about 15 watt multiplied with 10? You get 150 watt. What about 15 milliwatt multiplied with 10? You get 150 milliwatt. So you see, what I want to show you is actually that the decibel is a representative of a value without a unit. Okay, decibel ini adalah representative untuk value yang tidak ada unit. So value without a unit multiplied with another value with a unit, so it will follow the unit of that value. Like my example, this is 10. Okay, so I use this different unit for the power. For example, 100 micro, 100 microwatt multiplied with 10. So I will produce, for example, 15 microwatt multiplied with 10. So I will produce 150 microwatt. So that's the concept like that. Boleh? Ada soalan lain? Do you have another question? Ada lagi soalan?
No, that's it. Thank you.
Yeah, you want to ask question?
No, that's it. Thank you.
Okay. So if there's no question, maybe I want to go through another slides. Boleh? If you don't have questions, I will move to the next slides. We just browse through. Kita akan we will move faster. Okay, we will move faster about this one. Okay, this is another notes given in the author, already been given in the author. So this is about the calculation of dB, dBm and dBW. This is a good slides that I suggest you to learn from here. Okay, because most of the calculation we already seen this calculation before. Okay, so let's do the let's go through faster. Convert the following power gain values into absolute value. So from 10 dB, 0 dB and minus 10 dB. So what you can do is like this. So from 10 log of A, okay, it is how much is, we want to find how much is A. So NT log of 1, so you get 10. Okay, so we need to divide with 10 first. Okay, bahagikan dengan 10 dulu baru kita buat. Then we do the anti-log process. Okay, 10 log A equal to 0 dB. A is equal to anti-log of 0, which is equal to 1. 10 log A equal to minus 10. So that means A is equal to anti-log of minus 1. So you get 0.1. 0.1 is loss attenuation. Convert the following values into dBm. So you need to divide with reference value 1 milli. Okay, so what you need to do is 10 log power divide with the reference 1 milli. So you get 1 milli like this. So it is equal to minus 30 dBm. And then 10 log power divide with the reference 1 milli. So you get 10 log 1, which is 0 dBm. Here 10 log 1 watt divide with 1 milli. So you get 30 dBm. Okay, so the dBm, the word m here means that the reference value is 1 milli. If here is micro, the reference is micro. If here is dBW, the reference is 1 watt. Okay, convert the following in dBm into milliwatt. So convert dBm into milliwatt. So you see that here we want to convert into milliwatt. Okay, so 10 log of P in. So you see that previously I used X. Remember, previously I used X. 10 log X equal to minus 30 dBm. So everything inside here is actually in term of milli. If this is in term of milli. Okay, kalau di sini milli, maknanya di sini akan jadi milli. If this is dBW, that means over here is in term of watt. If this is in term of microwatt, that means here is microwatt. Okay, so anti-log of this you get 1 times 10 power of minus 3 milliwatt. Okay, anti-log of this, okay, so you're gonna get anti-log of 0 you get 1, but the unit is in term of milli. Okay, 30 dBm change into power. Okay, so 10 log power in the bracket is in term of milliwatt. So 10 anti-log of 3 you get 10 power of 3 milliwatt. Okay, convert the following power values to dBW. So this is easy. So convert this into dBW. So 10 log of power. So 10 log of power. The reference value is 1 watt. So normally we don't put the 1 watt here. Okay, kita tak letak 1 watt di sini Okay, because 1 is 1. Okay. Convert the following dBW to watt. That means you need to do the anti-log. Okay, you need to do the anti-log process. Okay, 10 log power in bracket. So this is actually power divided with 1 watt. Okay, since this is dBW, so we know that everything inside the bracket must be in term of watt. Okay, so anti-log of 1 we get 10. Okay, anti-log of 0 dBW, okay, divide with 10. So 10 log log P in W equal to 0. To anti-log of 0 you get 1 watt. Okay, so 10 log P in watt we get 30 dBW. So remember, this is watt, that means everything inside here must be in term of watt. Anti-log of 3 we get 10 power of 3 watt. So this is 1000 watt. Nampak Combine power in log scale. This one 1 milliwatt plus 1 milliwatt, so we get 2 milliwatt. This is simple. Okay, and determine 0 dBm plus 0 dBm. So 0 dBm cannot directly plus with 0 dBm. You can plus 0 dBm with 0 dB, no problem. Sorry, dBm with dB, no problem. But it cannot be the same unit. Okay. So if this happen, what you need to do first is to convert both of it into power. Convert 0 dBm into power. So you get 1 milliwatt. So 0 dBm plus 0 dBm. So that means 1 milliwatt plus 1 milliwatt. Then you get 2 milliwatt. From here, then you can convert into dBm. So 10 log 2 milliwatt divide, so this is actually 2 milliwatt divide with 1 milliwatt reference value. So 10 log 2, so becomes 3.01 dBm. Be careful, class. You cannot do dBm plus dBm. Okay, similar with dBW plus dBW. You cannot do like that. Okay, dB micro plus dB micro also cannot. Okay, what you can do is either dBW or dBm or dB micro plus dB. This you can do directly. Okay, another example. This is good. This is okay. 0 dBm plus 3 dB. This is power. This is absolute value actually. So you get 3 dBm directly. Or this is 0 dBW plus 3 dB. So you get 3 dBW. If this is 0 dB micro plus 3 dB, then you will get 3 dB micro. Okay. Another one. Example, determine 0 dBm plus 0 dBm. Of course, you cannot do directly. Forbidden. Mathematically is forbidden. So express your answer in dBm. Okay. So what you need to do is you need to convert each of this into power. Then you do the summation. Then you convert. Okay, mula-mula kena convert kepada power. Tambahkan. Kemudian tukar kepada dBm. Change to dBm at the end. Okay. So 0 dBm change to power. So you get 1 watt, 1 milliwatt. 5 dBm change to power, you get 3.1623 milliwatt. Okay. So what you need to do is you need to plus both of these. Do the summation. Okay. You need to do the summation. Then you get this one, 4.1623 milliwatt. From here, you can do the conversion to dBm. So 10 log, okay, so 10 log 4.1623 milliwatt divide with reference value 1 milliwatt. Okay, so that's why 4.1623. And then when you do the conversion, you get 6.193 dBm. Okay. Next, 0 dBm plus 0 dBW. So this is not allowed. Okay, because this is power and also power. It is not allowed. You need to change into power in watt first. Okay, so you see that 0 dBm change into power, so you get 1 milliwatt. Okay, 0 dBW change into power, so you get 1 watt. So you need to plus both of these, 1 watt and 1 milliwatt. So you get 1001 milliwatt. From here, you can change into dBW. Sorry, dBm. Okay. So 1001 milliwatt divide with reference 1 milli, and then do the 10 log of this. 10 log of this. So you get 30.0043 dBm. Okay. And if you want to convert into dBW, you can also do like this. 1001 milliwatt divide with reference 1 watt. Okay, so you will get this one 0.0043 dBW. Boleh juga. Okay, so you need to practice this a lot. Okay, you need to practice this a lot because this kind of calculations will come out in the tests and also the final exam. Remember, dB watt, dB power, dB power cannot be summation, cannot be directly calculated using summation. Okay, dB power and dB power cannot be plus both of it. You need to convert into power first, then convert again into dB power. Okay, any question? So that's all for today. Next week there's no class for next week because next week is public holiday in Johor. 1st of Ramadan is a public holiday in Johor, so there's no class for next week. Okay, remember that. Okay, no class for next week, but I will give you the video so that you can study. Okay, I will give you video so that you can study, and maybe later I will give you a quiz based on the given video. Okay, because I want to know whether you watch my video or not. Okay, whether you watch my video or not. Maybe later I will give you a short quiz regarding the next video so that from there you can answer the short quiz. Okay, different from section 2. Section 2 don't have a public holiday next week. Okay, so there's no short quiz for the section 2. I will inform you about the short quiz later. Okay, so now we can take the attendance. So almost 5 o'clock. So today I complete before 5 o'clock. Okay, so you can take out your QR code reader, you can scan your attendance, and then you can go out. Okay, so section 1, so now is 27. Okay, you can scan.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Welcome. Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, thank
you,
you.
Doctor.
Okay, welcome. Anybody else?
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome. Anybody else? Already scan your attendance?
Thank you, Doctor.
Okay, welcome. Siapa lagi belum scan? How many of you
Doctor,
hasn't
saya
scanned the
dapat
attendance? Nama siapa? What's your name?
Haris Kumar.
Haris Kumar. Okay, I will take your attendance.
Doctor, me also.
What's your name?
Okay, thank you, Doctor.
Okay, welcome. Sorry, what's your name?
Agilan.
Hagilan. Agilan, okay, I will take your attendance. Okay, done.
Thank you, Doctor.
Okay, welcome. Who else? Siapa lagi belum scan attendance? Okay, 3, 2, 1. So I assume 3 students are absent today. Anybody else? Samir. Why you cannot speak, Samir? What happened? Oh, I don't have microphone. Okay, Samir, your name is Ahmed Samir. So your name is Samir, Ahmed Samir. Okay, I will take your attendance. Okay, Samir. See you again. Okay, welcome.